Let me show you two different ways to do this question. First of all, this is how the answers did it. They noticed that we're using the numbers from 1 to 6, and actually they appear, each number appears on two circles basically. And so if I was to sum all the circles together, then it would be two lots of 1 plus 2 plus 3 plus 4 plus 5 plus 6. And that is going to be 2 times a half times 6 times 7. I'm just using the formula for triangle numbers here. Arguably, it might be quicker to just add them, 21 times by 2. But in any case, we get 42. That means on a single circle, it's going to be 42 divided by 3, 14. The numbers are going to add to 14. So if we focus on the circles containing 6 and x, we've got this blue one, and we've got the red. Now, what is necessarily going to happen is that the sum of, let me shade these in, this, and this is going to have to be 8 to get 14 overall. And then for blue, it's going to be very similar. It's going to be this one, and this one add to 8. Now, how can we actually get 8 from the remaining numbers? Three numbers, that is. Well, we could do 1, 2, and 5. Or we could do 2 and 3 is not going to actually work because it would end up being 2, 2, 3, 3. So 1, 3, and 4 would also work. Now, in both cases, there's a 1. And so that is enough to say that this is shared on both of them. So, either the red one's going to have to be 1, 2, 5, and the blue one, 1, 3, 4, or vice versa. But because they have to be the same here for both of them, this must be a 1. So nice argument, although I didn't think to do it like that. I did it in a slightly different way. So I'm just going to share a second method. So what I did is I decided to label this one A, this one B. I actually called X C when I did it. So let's call it C, D, and E. So then comparing some of these, I'm just going to focus on this circle here. I can see that it's got 6, D, C, and A. And then this one over here is A, B, D, and E. And then over here, we've got 6, B, C, and E. Now, comparing some of these, we can see that um, in the red one, I've got 6 and C. And in the blue one, I've also got 6 and C. So it must be that B plus E is equal to D plus A. Okay, we'll come back to that in a minute. Now, what are some other comparisons? Well, in this blue one, I've then got D and A, and I've also got D and A in here. So I can also see that B plus E must equal 6 plus C. So in fact, I've got a little equation going on. And then I decided to try some different numbers. So if C is equal to 1, then obviously I've got 7 from 6 plus C. And how can I make 7 otherwise? I've already used 1 and 6. So I could use 2 and 5, or I could use 3 and 4. Okay, so C equals 1 could work in theory. Let's see if anything else works. So C is equal to 2. I've got 8. And then I'd have to use 3 and 5. Remember, I can't use 6. But it's not actually possible to get a second one. So C can't equal 2. And if I go even higher, 9, that's not going to work either. So the only kind of configuration that would work is C equals 1. So very different way of arguing it, but to get to the same answer, it must be, remember, I've called it C, but I mean X. It must be that X is 1.